He literally defended his thesis on a Friday, and he started work on a Monday. Now, I'm sure he did his legwork before. He might tell you about that. It didn't just happen, but it can work that way. And so he has worked at the NASA Lewis Research Center, as it was then known, and now NASA Glenn. And he helped to start and is now the lab chief of the Mobility Lab. Now, mobility isn't just getting around, but mobility in the sense of space exploration at NASA means getting around on other worlds. And that actually is a very tough job because you deal with temperatures that are not anything like we face on Earth, and terrains we don't have on Earth, atmospheric pressures, the composition of the chemicals around you, all that is different. And so it is a very tough job. And so he has been at NASA Lewis and then NASA Glenn for his professional career, rising through the ranks. And now he actually heads a lab which is very deeply involved in the surface exploration of not just the moon, but other solid bodies in our solar system. So he's our second speaker, Dr. Phil Abel. Our first speaker, Dr. Ferenc Pavlic, was born in Hungary, and he did his master's degree in mechanical engineering at the Technical University of Budapest. In 1956, there was a revolution in Hungary. They tried to throw off the Soviet Union's dictatorship and yoke, and he got out to the United States, where he was hired by General Motors in the 1950s. Now, they didn't hire him to design the Edsel. They hired him, actually, to work in a very special research lab, along with some other Hungarian engineers who came out, on traction and working with how vehicles can manage in various different terrains. So he was in Detroit for about 3 years, and then they transferred him to Santa Barbara, California, where he was working on Department of Defense and the newly formed NASA on problems of various sorts of ways to propel vehicles in various sorts of terrains. This is 1957. A few years later, well, that's when he came to the United States. So around 1960-61, he started to work on these various DOD and NASA projects. Now, around that time, President Kennedy said we're going to the moon. And of course, if you're going to go to the moon, you have to get around. How do you get around on the moon? Nobody knew, because we didn't land on the moon yet. We hadn't even orbited it. We had very little information about it. So he was involved deeply in the research and eventually became the head engineer of the NASA Lunar Rover program. And later on, after the Apollo missions ended, he worked again for General Motors in Europe in various capacities. And then he consulted with the Mars Pathfinder and the Mars Exploration Rover Spirit and Opportunity missions. So this distinguished visiting engineer deeply knows how to get around on other worlds, not just the moon, but on Mars. So I introduce to you a very unique Bullitt lecture format, a dual format for 40 years of lunar exploration. This is the 40th anniversary of the Apollo 11 landing. This is the International Year of Astronomy, the 400th anniversary of Galileo's first turning the telescopes to the heavens. This is even International Space Week, which celebrates the first launch of the Sputnik satellite and the International Moon Treaty 10 years later after it was launched. And also in the name of our benefactor who died on the last day of the pre-space age, William Marshall Bullitt, I present to you Ferenc Pavlic and also Phil Abel.
I am honored to be invited as one of the speakers for the Bullitt Lecture, which is a very prestigious event. And my presentation will be a look back of the Apollo Lunar Roving Vehicle program, which I was fortunate to be part of as the engineering director for the General Motors research at Santa Barbara, California. We have worked together with the Boeing company as team members and received a contract from NASA exactly 40 years ago in October. We started out in the early 60s researching what kind of vehicles would be the best for lunar locomotion, since at the time there was no information available what kind of terrain, surface is on the lunar surface. We looked at all kinds of different vehicles, wheeled vehicles, track-laying vehicles, even a screw-type vehicle. One astronomist, Dr. Gold of the Cornell University, postulated that the moon is covered with a very thick layer of very loose, soft material, and everything you put on the surface is going to sink. So we came up with this Archimedean screw vehicle, which would be able to burrow itself through the loose soil, even underground. We built scale models, working models of these concepts, and tested them in a soil bin, which is the equivalent of a wind tunnel used in aeronautics. As soon as the Apollo program was announced, NASA was dreaming up this very different type of concepts of lunar locomotion. The scientists and NASA both agreed that there will be some kind of vehicle desirable to efficiently explore the lunar surface. The first concept, shown on the upper right of the slide, and it's on the upper right because they scanned the slide in reverse. It was a small vehicle designed for the Surveyor spacecraft, which was launched in the mid-60s. It was a 100-pound vehicle, very small, using solar panels, and to be operated direct remote control from Earth. The 2.5-second time delay still allowed a direct remote control, although it was somewhat disturbing. This project never got beyond the engineering model development because of schedule and cost problems with the Surveyor program. And the two Surveyor spacecraft landed on the moon without this little vehicle. However, the information which they sent back concerning the lunar surface, they actually measured the soil mechanics properties of the surface, allowed us to come up with a lunar terrain model, which we then used in designing future vehicles. It turned out that the lunar surface is not as fluffy, powdery as Dr. Gold imagined, because the Surveyor didn't sink, and the test indicated that the soil is something like a wind-blown loose sand, such as exists in sand dunes. As the Apollo program got underway, NASA had grandiose plans to send a vehicle like shown on the upper left corner called the Lunar Mobile Laboratory to the moon, which would have had a pressurized cabin where two astronauts could